Greetings, math fans. Alright, so today we're going to do a little bit more on half angle. I'm doing this because kids kind of get a little confused with the radicals, they get a little confused on the signs, and I want to just make sure you guys are kind of good to go with this. So I've got really two examples to do with you guys, one with just actually finding the half angle, and then the other one using the triangle problem. Okay, so let's get started. So half angle. Right. You recognize a half angle because it's going to be either pi over 8, or just think of half of 45 is going to be 22.5 degrees. So if it's half of 45, or if it would be like half of 135, so anything with a 45 degree reference angle, because think of, right, pi over 8 is half of pi over 4. So if it was like half of 135, it would be 67.5. So I mean, it's really easy to recognize it. You know, here 225, right, divided by 2 half, that 112.5. You know, 315 divided by 2 gives you 157.5. I mean, again, pretty obvious to use half angle. Now, obviously, if you have a problem that is 15 degrees, you could use half angle, but I don't think I'd recommend that. I think if I had something with 15 degree angle, I would use, or like a 75 degree angle, I think I would use sum and difference. That's my call, but it's your call what you want to use. But if you have a pi over 8 or something 22.5 or 67.5 or one of those, you have to use half angle, because there is no, I mean, think logically, there's no sum or difference for 22.5. Doesn't make sense. Okay, so let's just start out with a nice little friendly problem here. And if I did the cosine of 27 pi over 8, that kind of encompasses everything. Well, first of all, 27 pi over 8 is bigger than 2 pi. So you want to actually make it more manageable. And do you guys agree 2 pi is 16 pi over 8? So if I do that, I really get cosine of 11 pi over 8. And that's a little bit more manageable. Okay? Alright, so you're going to start out the problem by saying cosine of, it's 11 pi over 4 over 2. Okay? And so we know we're going to have plus or minus the square root, just plugging into a nice little friendly formula for cosine. So again, you need to know your double or your half angle formulas. So it's going to be 1 plus cosine of A, and A is that number on top there, so it's 11 pi over 4 over 2. Okay? Now here's the deal. This plus or minus, this is based on the original angle. It's based on the cosine. I mean, we could use this one, but it's really based on, you know, we can do coterminal. But it's based on 11 pi over 8. And you got to think to yourselves, well, where is 11 pi over 8 located? And you guys agree this is 8 pi over 8 here? And this is 3 pi over 2 over the bottom here, so it's going to be 12 pi over 8. That means 11 pi over 8 is somewhere in this quadrant here. So then that's how that plus or minus works, and you're going to say, well, cosine, what's cosine in that quadrant? Cosine is negative in that quadrant. Okay, so that means we're going to have negative of that value. So negative square root of 1 plus cosine of 11 pi over 4 over 2. Okay, now we have to do, this is, I know it's not necessarily tricky, but kids seem to get this wrong, is you got this part right here, the cosine 11 pi over 4. I mean, this is from chapter 3. You should not get this wrong. Cosine 11 pi over 4. Well, first of all, as I did with the one before that, the 27 pi over 8, I can do coterminal because it's bigger than 2 pi. So if I subtract 2 pi, which is 8 pi over 4, I really get cosine of 3 pi over 4. And again, this is looking at where this is, 3 pi over 4 is here, and you guys agree it's negative as well. And so actually cosine 3 pi over 4, reference angle is root 2 over 2. In fact, they're always going to be root 2 over 2, just because everything is going to be something based on a 45 degree angle, right? You know, with pi over 4. So that's just kind of nice. You know it's going to be root 2 over 2. So I have my problem now as negative square root of 1, and then it's basically cosine of 3 pi over 4, so it's 1 minus root 2 over 2 divided by 2. Okay? And then you need to simplify it. So actually I'm going to multiply the top and the bottom by 2 over 2. That gets rid of the fraction. So I have negative square root of 2 minus root 2 over 4. And really that square root of 4, you don't want to leave a radical in the denominator, and that's easy because for this one, especially for all these problems, if I want to do this, I can rewrite it as 2 minus root 2, square root of that, all over square root of 4. So then my final answer is negative square root of 2 minus root 2 over 2. That is the final answer. So you just got to be super, super careful with signs. That's probably the biggest error that you can possibly make here is issue with signs. Okay, but remember the original. This sign is based on the original problem, the half angle. Okay, the saying what's cosine of 27 pi over 8? Where is it? Okay, and then just be careful of this sign as well. Okay, that belongs to, and I just take the cosine of the 11 pi over 4. Okay, so let's do a triangle problem now. Okay, so here's the example. It'll be find the sine of theta over 2 given sine of theta equals negative 1/5, and theta is between 270 and 360. Alright, so you draw your triangle, pretty easy, and obviously if it's between 270 and 360, you're in the fourth quadrant here, and so we have y over r, so negative 1 and 5, and using Pythagorean theorem, 25 minus 1 is 24, root 24 is 2 root 6. Okay, and so again, we'll always watch your signs. So then we have sine of theta over 2 equals plus or minus the square root of, I'm just going to write the equation out, 1 minus cosine of theta over 2. Okay? Well, this plus or minus, math fans, this plus or minus right here is based off of what is theta over 2. Not the original angle like the past problem. It's based off of the half angle. So think about it. If you're in this quadrant, if you're in this quadrant here, and I take half of that, where does that put me? Well, if you're not sure about it, just think logically. Here, 270 and 360. If I divide that by 2 and that by 2, it's between 135 and 180. Everybody agree with that? I don't really hear anything, but I guess you're saying yes. Okay, so 135 and 180, that puts me into that quadrant right there, into the second quadrant. All right, and then you're going to say, well, what's the SIGN? Is it positive or negative? Well, sine, remember from all students take calculus, sine's positive there. So the sign is going to be plus. Okay, that's really, really, really important. Okay, and that's actually probably the trickiest part of the whole thing. The only thing I need here is I need cosine. And do you guys agree? Cosine of theta is going to be x over r, so it's just going to be 2 root 6 over 5. So we got 1 minus 2 root 6 over 5. Okay, and then it's positive there. That's right. Okay, that's good because again we're taking the ratios directly off of here using those signs, and that's over 2. So the first thing I want to do is I want to get rid of that 5. I want to get rid of the complex fraction. So I'm going to multiply the top and bottom by 5 over 5, and that gives me positive the square root of 5 minus 2 root 6 over 10. Okay? And now I want to rationalize this. Now sometimes people do some goofy stuff and they split it up ahead of time. If you leave it, I'm just going to write over here just so I have a little more room. 5 minus 2 root 6 over 10. So basically, I'm just going to extend this radical, and I'm going to multiply the top and the bottom just by 10 over 10, because that's going to give me a perfect square right there. Okay, and that's what I want to do. But if you put it on the outside, then people get confused on where do you multiply as far as the top. Do you multiply 2 root 6? So is it root 6 times root 10? It's kind of complicated. So if you keep it all under the radical, it makes life so much easier, because then I just say, oh, 10 times 5 is 50, and negative 2 root 6 times 10 is negative 20 root 6. See, oh, don't multiply by the root 6. It's by the 2. Okay, so just keep it on the outside, and then of course there's a square root there, and then the bottom is, actually I'll just put the whole square root there, and the bottom is going to be 100. Okay, and then if you want to, you can split it up to say square root of 50 minus 20 root 6 over the square root of 100. You know, I'm kind of showing an extra step here, and then your last step is going to be, and again, this is all positive. I didn't write that plus anymore, but it's square root of 50 minus 20 root 6 all over 10. And it's positive, so I'm not even going to write the positive. Okay? And that is your final answer, math fans. Okay? So you don't have to do any more with the radical on top, but as long as the bottom you've got it rationalized, you are good to go. All right? So that's just an extra little explanation for half angle, and hopefully you guys are good to go. That's it, math fans. Have an outstanding day. Adios. Goodbye.